Hey everybody, this is Matt with mathmath.com. Thanks for joining us here today as we talk about ratios of similar figures, especially dealing with area and volume. Well, we are in the Math Common Core Standard of Geometry, and today we're going to be talking about similarity and using physical models, especially in geometry having to do with area and volume. Let's get started. Our guiding question says today that how does the size of a shape affect its perimeter, area, and volume? Do you have any idea? When you double the length of the sides, what does that do to the perimeter? What does that do to the area? And if you have a 3D object, what does that do to the volume? Well, that's what we're going to be answering today. So here's just a quick shape that we'll start off with. We've got one square here. Notice that through each progression here, we have doubled the lengths of the sides. So you have a length of 1 here, a length of 2 there, and a length of 3. What does that do to the area of the figure? What does that do to the perimeter of that figure? Well, that's what we're going to be talking about today, okay? All right, well, what's the difference? Well, if we do look at perimeter, area, and volume, we're going to be talking about ratios today. We're talking about if we shrink something or if we enlarge something, we're going to notice some patterns that pop up. All right, so let's compare our answers as we go through this. All right, we're going to find the perimeter area of the new object here when we multiply it by 2 times, 3 times, and 4 times as big as the original object. All right, so notice here we've got 1, 1, and 1. That's the dimensions of this guy. So the perimeter there would be 4, right? And the area would just simply be 1. Right? So the perimeter would be 4 because there's 4 ones, and then the area would just be 1 times 1. Now, look at this guy. The next one, we've got a length of 1, 1. So this is 2, and a length of 2 there. So the perimeter is 2 plus 2 plus 2 plus 2. So the perimeter there would then be 8. Whereas the area is 2 times 2. So that's 4. All right, so perimeter is 8, area is 4. Let's multiply our lengths by 3 and see what we get. Now we have a length of 1, 2, 3. 1, 2, 3. We've multiplied the original length by 3. So it's 3 plus 3 plus 3 plus 3. So that area is 12, or the perimeter is 12. Whereas the area is 3 by 3. It's 1, 2, 3, 4, all the way up to 9. So 3 by 3 is 9. Our perimeter is 12, area is 9. Seeing any patterns so far as you're writing these down? If not, let's keep going. We'll definitely see it here in just a second. All right, so now we're going to multiply by 4. We got 1, 2, 3, 4. 1, 2, 3, 4. So we've taken the length and we've quadrupled it, multiplied it by 4. So the perimeter is 4 times 4, which is 16, because there's 4 sides. And also, it is 4 times 4 is the area, because there's 4 here and 4 there stacked up, and that gives us 16. So perimeter is 16 and the area is 16, and that's special. All right. Now, would you do these ones for me? Take the triangles, and you're going to take the lengths and double it and triple it. And what I want you to do is I want you to see if you can find a pattern. Now, what I want you to notice here is that the first one, the perimeter is 3, right? 1, 1, and 1, that's 3. And what I'm going to tell you the area is of this rectangle, you're not going to actually find it. We're going to say that this area is B. And by calling it a variable, you'll see a pattern compared to the previous problem that we just did. So if the area is B, how many areas do we have here? You would just count each individual triangle. So you got 1, 2, 3, 4. So instead of area right here and writing B, you would write 4B. There are 4 B's. So go ahead and find the perimeter and the area of each of these shapes. All right, now do this big one. All right, here are your answers for number 2. Notice here that 4, 9, and 16 were the same numbers we saw last time. How could we get 4 when we double it? How could we get 9 when we triple the lengths? And how would we get 16 when we multiply the lengths by 4? Any idea? If you do, that's your hint. That's your pattern. All right, so let's do it with a rectangle here. Let's double the lengths, let's triple the lengths, and quadruple the lengths, and see if we get that same pattern, okay? Figure out the perimeter and the area first. Here it is. Perimeter is 2 plus 2, which is 4, plus 1 and 1 is 6, and the area is just 1 times 2. Now what I want you to do is I want you to double the lengths, so instead of 2, put a 4 there, instead of a 1, put a 2 there, and then find the area and the perimeter, okay? Now you're doing the same thing with 3 times as much. So instead of 2, you're going to write a 6, instead of a 1, a 3. And now you can do the same thing with 4 times as much. So instead of a 2, an 8, and a 1, you'll put a 4. Seeing some patterns? Bet you are. All right, one more. Let's do it with parallelogram. Again, there's the perimeter. Area is C. I'm not going to tell you what the area is other than C. Okay? So what I want you to do, again, is double the lengths, tell me the perimeter and the area, triple the lengths, tell me the perimeter area, and quadruple the lengths and tell me the perimeter area. And guess, maybe even try to guess what this one's going to be. See if you can do it on your own without even calculating it or adding it up by multiplying these by 2 or multiplying these by 3, whatever. All right, did you guess it right? Remember, when we double it, looks like we're multiplying it by 4. When we are tripling it, we're multiplying it by 9. And when we're multiplying it by 4, we end up multiplying the area by 16. That's our pattern there. All right? So if we wanted to write the charts in here, notice we could do something like this. We would fill everything in here with the original value, whereas when we have the perimeter, what do we do? Have you picked up the pattern yet? Multiply it by 2. Whereas the perimeter, if we triple the lengths, we multiply the perimeter by 3. And if we multiply the lengths by 4, we quadruple the perimeter. Whereas with area, if we double the length of the sides, we don't multiply it by 2, we multiply it by 2 squared. Did you figure that out? Whereas here, 3, we don't multiply it by 3, we multiply by 3 squared. And we don't multiply by 4, we multiply by 4 squared. So we put a 16 there, 16, 16, and 16. 9, 9, 9, 9, 4, 4, 4, 4. Okay? That's what we would fill in there. Right. Now, here's our ratios. What we're going to look at now is the different ratios between the two. And this is just the generic statements that I'd love for you to write down of the ratios comparing perimeter, area, and volume. Now, if you think about it, when we look at area here, area, if you think about what the units are of area, if it was inches, the length through inches, area would be what? Inches squared. So it would make sense that when we look at the ratio, we don't use the original ratio of 4 to 6. We use the ratio of 4 squared to 6 squared. We actually square it because of our units. Now think about what volume would be. Think about what our units are in volume. They're not inches squared nor are they inches. They're inches cubed. So the ratio wouldn't be 4 to 6 if we have the lengths compared that way. It would be 4 cubed to 6 cubed because it's volume. All right, so for perimeter, area, and volume, here are our here's our equations. For the ratio, we compare just the length of figure 1 to the length of the second figure, and that's it. So if it was 4 here and 6 here, it'd be 4 to 6. And you just simplify it. So it's just A to B. Whereas with area, we do A to B, or 4 to 6, but we square it. We square each of those. So now it becomes A squared to B squared. We take that same ratio, we just take one side and compare it to the other side. If one side was 4, the other side was 6, you would just put 4 there, 6 there, and square both sides. And that's it. And with volume, we cube it. Thinking about what inches, or the measurement of inches cubed, we would take our ratio and cube our ratio. So it would be 4 cubed to 6 cubed. That's our ratio when we compare the two different volumes of these shapes. Okay? So I want you to compare the volumes here. We've got one cylinder here with a diameter of 12 and a height of 5 centimeters, as well as 6 centimeters in the diameter and 2.5 centimeters in the height. All right, we're finding the volume. To find the volume of a cylinder, if you remember, it is just taking the area of the circle here, which would be pi r squared. R is going to be 6, so we'll do pi times r squared. So take the 6 and square it. That's going to give us 36. And then we're going to multiply it by 5 here. Okay? So that's the volume there. And then notice I'm not multiplying pi out. I'm just going to leave it the way it is. Okay? So this becomes 180 pi. And we're going to compare it to the volume of this guy over here. Notice our radius is what? It's 3. So we're going to do pi r squared. So pi with r squared being 9 times 2.5. Okay, 2.5. And we're just going to leave pi on the outside. and then we'll do 2.5 times 9, 22.5. Okay, and if I wanted to, I can just cancel out the pi's there. Just like simplifying a fraction, you simplify a ratio by taking out the pi's. All right, and this is then going to be our ratio of the volumes. Now, what's the ratio of the radius or the lengths? Notice we're taking 6 and we're going down to 3. We're just halving it or doubling it if we're going back the other way. So our ratio then of lengths, if we're going to write it there, would just be here it's 2, here it's 1. 2 to 1. So then therefore our ratio over perimeters is also 2 to 1. And our ratio of our areas or surface area here would be 2 squared and 1 squared, which would give us 4 to 1. And our ratio of our volumes is not 2 to 1, it's 2 cubed to 1 cubed because it's volume. So then it's 8 to 1. I bet if you take 22.5, multiply it by 8, you'll get 180. There it is there. Here it is here. Just recapping. Comparing the volumes, the ratio is 1 to 8. All right, would you do these guys? I want you to find out what the length of this x is. If you know that the volume is 720 cubic yards and it's 6 by something by 15, what is x going to be? Well, you don't actually need to work backwards. How do you go from 6 to 4? What's that ratio? Well, you just simply write 6 to 4, and then we reduce it to 3 to 2. So that's the ratio of both the perimeters and the lengths. So if I wanted to find x down there, I set up a ratio. Now, I don't know what the length is here, so I do need to work backwards to figure out what that length is. I will need to multiply 6 and 15 and then divide 720 by that number in order to get that length right there. Can you do that? Or you have another way to do it? If I know that the ratio is 3 to 2 for the perimeters, what's the ratio for volume? Well, if you remember, we'll take 3, cube it, and 2, and cube it. So this becomes the ratio of the volume is 27 to 8. So if we set up a proportion, 27 over 8, and we know that the big one is 720, cross multiply and divide, and that would give you the volume of the smaller one. And then what could you do? You could work backwards to find x. All right, and then here's your answers there. All right. Find the ratio of these two shapes for the perimeter and the area. Remember, it's pretty simple. All you do is compare those sides there. And for area, you square it. And don't forget, like on number 2, you're going to simplify those fractions, okay? All right, work with a triangle there. And you buy 2 picture frames that are similar, and the ratio of the corresponding sides is 4 to 5. What's the ratio of the areas? All right, here they are. How you doing? You getting it? Not terribly difficult, as long as you know you can. All you gotta do is compare the sides, put them up in a ratio, and leave it for perimeter, square it for area, and cube it for volume. And that's it. Well, thanks for joining us. Did you able to figure this and answer this question out now? How does the size of a shape affect its perimeter, area, and volume? All right, I bet you can. Well, thanks for joining us as we talked about ratios of similar figures, both in perimeter, length, area, and volume. This is Matt with MathsMath.com. Check us out on Facebook at Solving Maths Problems, and on Twitter at Maths Math, and enjoy math.